Okay, so we're going to walk through this step by step. So we have a record of this up on YouTube. So balancing a lactating cow ration, and we're going to use net energy lactation, NEL, as our measure of feed energy. So we're going to use the assignment lab 11, number 1, as our example here, and we're going to go through it step by step. So that number 1 was possibly a Canadian diet, balance a ration for a 1,500 pounds second lactation cow, producing 80 pounds of 4.0 milk, using table 2, for dry matter intake in pounds per day, net energy lactation in megacals per day, crude protein in pounds per day. Assume her dry matter intake is 4% of her body weight. For the feed composition table, use feeds 8, 19, and 54. To check your math, the amount of as fed should be about 102 pounds. Also calculate the percentage of forage dry matter in the diet. So for this ration, we're going to use these sheets here. You'll have these on the lab practical. This is what we've been using throughout the semester. Same 8 steps. We've used TDN, we've used net energy lactation as our energy terms. Today we're going to use net energy lactation. So step 1, determine the nutrient requirements in pounds per day for the animal described. So this is lab week 11, number 1. We take a look at feed table 2, or nutrient requirement table 2 from NRC 1989. So first thing we're going to look up is our maintenance requirements for a 1,500 pound animal. We're going to take the second column there, net energy, feed net energy in megacals. It's going to be 10.66, and crude protein is going to be 0.97. Step 2, we're going to figure out growth, and we go to the bottom of the page. We've got a second lactation animal at the end of that box there, 10% during the second lactation. So we take 10% of what's required for maintenance, and that becomes our allowance for growth. Third step is our 4.0 fat milk, each pound of that. So we got to remember for this, everything is based on 1 pound of milk, so you got to multiply by the number of pounds. So for net energy for the milk, we've got 0.33 for every single pound of fat. We got to multiply that by 80, and then our fourth column over, 0.090 for protein for each pound of milk. So we got to multiply that by 80. So in going back to our form and filling that in, step 1, maintenance. We've pulled the numbers from the chart there for net energy lactation and crude protein. So we've got those two right here. Dry matter intake, we use the 1,500 times 4%, or 0.04, is going to give us 60 pounds of dry matter intake to work with. Step 2, second lactation, that's a growth of 10%. So we take 10% of the maintenance requirements, gives us 1 megacal, a little bit over 1.07 megacals of net energy for growth per day, and then 0.097 pounds of crude protein for growth each day. Third step, 80 pounds of milk, 4.0. 80 pounds times 0.33 is 26.4. 80 pounds times 0.090 gives us 7.2 pounds. If we add up the 1066, 1.07, 26.40, that gives us 38.13 megacals necessary on a daily basis for this cow. Crude protein, add the three sources up there, 8.267 pounds of crude protein needed each day. Next step, step 2, find the nutrient composition of feeds to be used. So we told you we wanted you to use 8, 19, and 54. So going to our table, 15.1 gives us our feed composition. 54 is going to be designated as our feed number 1. It's low in energy relative to the other two and low in protein. The barley grain, number 8, is going to be designated as our energy feed. So our number 2 feed. Our number 3 feed is going to be 19, the canola meal mechanically extracted. So these 3 blue boxes here are where we get our numbers for our nutrient table. So we need dry matter percent in the middle here. On the right side, we have crude protein. We're going to use net energy 3x on the left side here. It's listed in megacals per kilogram. We're going to switch that over to megacalories per pound. So we take each of those numbers and multiply them by 0.454. Kilogram is 2.204 pounds. So to get the megacals in 1, we multiply by 0.454 to get our numbers here. So dry matters are listed as percent. So when we multiply, we got to divide through to get the proportion. So moving our decimal point over 2. Same thing with crude protein. Divide by 100 to move our decimal point over 2. The net energy lactation, since that's on a per pound basis, we can use that as is. So that's our feed table, designated 1, 2, and 3 feeds, grass silage, barley, canola meal. And there's the composition associated with each of those. We go to step 3, our trial ration number 1, balance for dry matter intake, or run trial ration number 1 with just feed 1. So to get our answers here, we're going to take the dry matter pounds, multiply by the net energy lactation. That's going to give us the megacals that feed 1 provides. So feed 1, grass silage, we're going to start out with 60 pounds of that. We multiply by 0.51, so we get a half a megacal for every pound, and that's going to give us very close to 60, or half, 30, so 30.6. We compare that to the requirement. We've taken the requirements of 60 pounds. That has to be met there. Are 38.13 megacals required. We are 7.53 megacals short. So we need to continue on with our ration balancing and proceed to ration number 2. To do that, we have to go through step 4. So balance for energy by first determining the gain of energy by substituting 1 pound of feed 2, our barley, for 1 pound of feed 1, our grass silage. And then second, by determining the amount of feed 2 required to make up the energy deficit. So figuring out the substitution gain. So we got to figure out the amount of feed, energy in feed 1, that's just the megacals listed. Megacals in 1 pound of feed 1, just the megacals listed. And then our gain is the difference between the two. We take our needed, we divide by our gain that we got from up there, and that gives us the pound of feed 2 we have to substitute, and then we have to figure out the new amount of feed 1 given that we're going to feed that much of feed 2. So how does this actually work out in this example? So feed 2, 0.84 megacalories per pound. Feed 1, 0.51 megacalories per pound gives us a difference of 0.330. So every time we take out a pound of feed 1, put back 1 pound of feed 2, or put in 1 pound of feed 2, we gain a third of a megacal each time we do that, 0.330. We take the deficit from step 3, 7.53 megacals. We divide by the gain we take from the step up there, and that's going to give us, we need 22.8 pounds of feed 2 to gain or fix our energy deficit. So we were feeding 60 pounds of grass silage. We have to substitute in our barley, 22.8. That's going to leave 37.2 pounds of grass silage dry matter as we move through. Moving on to step 5, we balance or check the balance of dry matter intake, NEL, and crude protein, or run trial ration number 2 with just feeds 1 and 2. So feed 1, grass silage. Our feed 2 is a barley. So to get our NEL megacals provided, we multiply the dry matter intake from that feed times the second column here, the net energy lactation, the megacals per pound. Pounds times megacals per pound is going to leave megacalories generated from that. To get our crude protein pounds, we're going to take the dry matter pounds in the first column, go over, multiply by crude protein divided by 100. We got to get the fraction of protein per pound, and that's going to give us our pounds over there. We bring in our requirements from the previous table. So we add everything up, gives us a total, generate the megacals, total those up, generate the pounds of protein in each of the feeds, total those up, compare those to requirements, and see where we should be. Mathematically, the first two should be 0. So pounds of dry matter compared to requirement, that should be 0. And then our net energy lactation should be balanced perfectly at 0. That's just the simultaneous equations should bring those to 0 or very, very close to that with rounding error. So let's go through the actual example. Grass silage, barley. We got from step 4, 37.2 pounds of dry matter from the grass silage, 22.8 pounds of barley dry matter, barley grain dry matter. We bring the concentrations of megacals here from step 2. We multiply the dry matter intake column times the net energy lactation column, and that gives us the megacalories provided by 37.2 pounds of grass silage and 22.8 pounds of barley. So the dry matter totals up 0, megacalories provided totals up 0 difference. So we're good with those two. We need to check our crude protein. We multiply the pounds of dry matter times the percentage of crude protein divided by 100. So 37.2 times 0.128 gives us 4.8 pounds of crude protein. 22 pounds of dry matter times 0.124 gives us 2.8 pounds of crude protein from the barley. Add those up, 7.589 pounds of crude protein provided by those two feeds. We compare that to requirements, and we are short 0.678. So we have to proceed to step 6. So balance protein, step 6, balance for protein by first determining the gain in protein by substituting 1 pound of feed 3 for 1 pound of feed 2, and second, determine the amount of feed 3 to make up the protein deficit. So again, we figure out how much protein is in each pound. We take the percentage, divide that by 100. That gives us the answer. The difference between the two is the gain by taking out 1 pound of feed 2, adding in 1 pound of 3-2. Every time we do that, we get our gain. We pull from step 5 the amount of crude protein needed. We bring down the gain from the line above and do the division there, and that gives us the amount of feed to substitute. We take the old amount of feed 2, we subtract the amount of feed 3 needed, and that gives us our new amount of feed 2. So we do this actual numbers. So 37.8%. In each pound of feed 1, there is 0.378 pounds of crude protein for our canola meal. For our feed 2, barley, 12.4% crude protein. So every pound of barley has 0.14 pounds, a little bit more than a tenth of a pound of crude protein in each pound of feed 2. If we substitute one for the other, we take out feed 2, put in feed 3, we get a 1/4 pound gain every time we make that swap. We bring down that 0.678 pounds of crude protein needed from step 5. We divide by the gain from the line above, and we get that we need 2.7 pounds of feed 3. Taking 22.8 pounds of feed 2, we're going to substitute in 3 pounds of feed 3, take out, or 2.7 pounds of feed 3, take out 2.7 pounds of barley. That's going to leave us with 20.1 pounds of barley, or our feed 2. We proceed to our final ration balance here. If we've done everything right, this should balance out, or at least close to it. So again, we're going to multiply the first column, dry matter pounds, times the net energy lactation, megacalories per pound. Multiply those two there, cross out the cross cancel the pounds. That's going to leave us with megacals provided by each of the feed ingredients. We take the first pound, multiply it by the fourth pound, divided by 100 to get the proportion of crude protein in each of the feeds. We multiply those two together, and that gives us our fifth column over here, which is the pounds of crude protein provided by each of the feeds. We total those up, we compare those to the requirements from step 1 and see if there's a difference. If we've done everything right with the examples I provide to you, this should come out fairly close, usually within 5%. Since I usually test the rations before I do them. Okay, so using our example, grass silage, barley, grain, canola meal. Here's dry matter first column, dry matter of each of the pounds that we need, or each dry matter pounds of each of the feeds, 37.2, 20.1, 2.7, that adds up to 60. Our requirement is 60, zero difference. We are at balance. We take the first column times the second column. That gives us the megacalories of each of these. They total up to 38.02. We need 38.13. We are short 1/10 of a megacalorie, 0.11, 0.11. That is within 5%, probably within less than 1%. So we are considering the ration balance for energy. We take the first column, multiply by the fourth column, divided by 100. That is going to give us the pounds of crude protein provided by each of these three feeds. if we do our math correctly, the amount total should meet the requirements. So with the math, the way the equations work out, dry matter intake should be 0 and crude protein should be 0. So across the board, 1, 2, 3 feed ingredients, we have a 0. We have a balanced ration. We have achieved balance. So this ration is balanced on a dry matter basis. We need to convert that in step 8, which is next up, to an as-fed basis. So we bring our 3 feeds down. We have the amount of dry matter for each of those, totaling up to 60. We go back to step 2. We pull those dry matter percents. We take the pounds of dry matter divided by the percent dry matter divided by 100 gives us the amount of as-fed feed that we need to put in the pile in front of the cow to feed her each day. Remember that the as-fed weight has to add up to something greater than the dry matter. We're adding water, so this should be larger. The as-fed pounds should be larger than the dry matter. So in our example, 37.2 divided by 36.5 divided by 100 is going to give us 101.9, which is right about where we wanted to be, about 102. Barley, dry feed, we're only going to add about 10% to that, so 20.1 divided by 0.91 is going to give us 22.1. 2.7 divided by 0.903 is going to give us about 3 pounds for a total of 127 pounds of feed. If you look at the difference here, 60 pounds of dry matter in 127 pounds as fed, we're going to be a little less than 50% dry matter for the whole feed. And if we look at the grass silage, our feed 1 is the forage dry matter provided divided by the total dry matter consumed, gives us a 62% dry matter diet. So here's all that all in one slide. Work through step by step, follow the instructions. The rations I give you should balance out and be coherent. I hope this is helpful. It's there as long as you need it, up on YouTube.